it arrived, and there's some good and there's some bad. And there was a lot more bad than there is now, but there was some bad, and rectified it to a certain extent, but the engine's going to require major work. This is Stuart No1. I don't think that the guy had a milling machine, and what I found when I was taking it apart was that let's see if we can get the right lighting here. The slide here for the piston was 2 millimeters out on the foot. I'm going to use my own terminology because I'm not quite sure all the British equivalents, but it was about 2 millimeters too thick at the foot part. So I had to mill that down very carefully because I wanted to leave more than an eighth there, or a 16th. And I got down to about a 16th, but I got it flat so that the rod is in line with the piston. Now, I think that this engine, this was expensive, I think, but 399 pounds. And then I gotta throw in another $100 in customs and shipping. The shipping was extremely fast from the UK, I gotta admit. It went through the global shipping program, and it was very, very quick. It took only about 8 or 9 days to get here. Now, the problem was that in the photo it said, check the photos, of course, carefully. They are part of the description, which is sort of a loophole these days. But it said it looked well built, and it was far from well built because the guy didn't have a milling machine. So this area here was done with a file for the stanchion that runs to here. The stanchion itself was drilled too wide for the two holes, the two BA holes that are here. So it was never going to attach with those two holes. So he had one bolt in it. I thought he was just missing the other hex head bolt. Unfortunately, I was wrong, and the stanchion never actually fit in the engine properly. So I will grab that. Hold on a second here. And show you the setup. Now this is a pretty basic stanchion. It's only a 1/2-inch rod, and you could hard solder a foot on it and re-drill it. So I might do that. I might make a whole new one, but I might leave this original one and actually fill both holes with TIG welding, and then re-drill it. But drilling through welds isn't always that fun. So what I might do is cut this down to where I can put it on the lathe, turn this with a 3/8 foot, or just under 1/2 inch, maybe slightly under 1/2 inch, and then fit a steel block on the bottom that I've machined to fit this area here with the proper hole spacing. Then make sure that the hole in the center is correct, because I want it to line up properly. So I'll have to make a mark on the actual block that I've machined, and then drill a 3/8 hole in the block, shallow 1/16 or 1/8. 1/16 probably a little, well, 1/8 would probably be okay. And then have TIG weld inside, so I TIG weld the rod into this steel block. The opposite, or the other option, is that I just press fit it in, press fit the rod into the block, and then by fastening this down and by fastening it on the top cast part, this can't lift out, so it won't really matter much if it's at least a press fit. It will support the vibration of the engine and put Loctite in there and all of that. Now, on the top of the engine, up here, I've got two holes. They don't go through to the piston area at all, into the bore, but they're tapped, I think, which is just crazy. The cat's sort of puzzled by it as well. But they seem to be tapped, and at least they're started, so I'm not sure if I'll drill through there or I will turn the engine around here and drill through here for my bleeds. I might actually put a bleed on the bottom cap instead to drain the water that way quickly through a hose or through a copper pipe. Because I've heard of people putting one bleed valve on the top. A gentleman in the States suggested that for a number 5 if I had bought that. So for running on steam, I've got the piston now freed up, and getting into the piston area, the top here, 2 BA bolts. I'm going to get my T, hold on a second. 2 BA bolts on the top there, and tapping not all the way through, which is nice, so that it's not too cosmetically damaged to the casting. But on the inside, the piston was 1.9995, and the bore was 1.9997. So with that, both the top and the bottom screw-on piston portions, the steel parts, were scraping the bore, and unable with the unmachined sliding foot here, when that piston was going up and down, it was too thick, so it was binding, and this rod was actually outwards this way, more like an angle like that. So it I don't think it ever ran, and despite the blackening around the castings, it looks like it's been run a lot. I thought it was a working engine actually when I bought it, so I wasn't expecting the best of conditions. I was expecting to replace bearings and that kind of thing. But it wasn't even machined to the point where it would run. And if it was machined at one point, the bore is pretty good. It's a bit glazed, so it does look like it was run. I think it was run with a different bottom end on it completely. So piston rod, crankshaft, and eccentric probably were replaced on this engine at some point, not machined by the same person who machined the bore, because the bore was quite exact on the inside. And everything else is very nicely done, not overly done, but nicely done. Like the head is very well finished, excellent fit on the head, excellent fit on the steam chest. I double nutted it here just to see what it would look like. Very good fit on the stanchion. The base is drilled very well. I'm not sure what the spacing here is supposed to be, but it's very well centered. So I think that this part was replaced afterwards by somebody else, because you can see right here, if I line that up, the foot is actually wider than the whole casting. It was never really intended to fit on there, so it was attached loosely this way. So we're going to fix that. We fixed the slider. That's ready as far as running goes. Repack it with the yarn that was in it. But the graphited yarn was completely brand new. It wasn't used at all. So I think that this is what in the British motorcycle world we call a bitsa. It was made of bits and pieces of all kinds of different engines, or maybe just a couple, but maybe an engine that was put together after somebody took the best parts and left this. The crank was off by about 1/2 inch, and I've gotten it down to perhaps a 1/16 now. So that was a whole another 3 hours of work. The crank is silver soldered. It's not a one-piece cast crank at all. I've got the shafts out, and on this shaft, I'm not sure you'll be able to see this, but I think you will be able to see it. Okay, when I turn the shaft there, tell me if you can see England. It says England right there, and then on this side of the shaft it said job number 2. So it said job number 2 or job 2 and then England. So it was a drill bit. Somebody used a drill bit to make the shaft, and it's straight, it wasn't bent. The shaft wasn't bent at all, which I thought I would have to replace or manufacture or buy a new one. But what was bent was the web itself. Right here in this area here, it was twisted. So when I tried to put the longer of the 2 drill bit shafts through both holes, I couldn't put it through. It was out about a 32nd to a 16th. So what I did was I put this in a vise with the bottom area where the shafts had been, and I put the shafts in to hold the diameter. Then on each end I had a shaft so that I could clamp it, and I clamped it very tight in the vise, almost too tight for the Chinese vise. Then I heated up the top here, almost cherry red, pretty darn close, as much as my propane torch will allow. And then I tightened the vise down because I had it loose on the bottom part. When it was cherry red, I tightened it down and let it cool in the vise that way. And it came out pretty true out of 1/32. So I straightened the web by clamping it in a straight jaw vise. And then I was able to slide one of the longer shafts through the web holes. And I could see that I'd corrected the alignment as far as this goes now. It does have a proper key on the actual flywheel, which is a good indication that somebody was serious when they built it. There you might be able to see England by my thumb there. Got the Manx cat getting in on the action here. Anyways, so this is going to be a bigger project, I think, and it'll be a little bit more work than I expected. And I'm going to have to make it work well for the money I've got invested in it already. I will be trying to get new bearings, I think. Split bearings. Perhaps I'll get the castings and then machine them, or have them machined by Stuart to a 1/2-inch shaft, and go that route, just so that I put some investment back into it and I know something is done to spec. But first we're going to get it running. So the cat's got the wrenches, and I've got the Stuart No1 now, which will go on the big plinth once it's running. See you later, guys. Bearcat. Psst, psst. I'm going to have to look at some pictures, but I've got the eccentric working now. And the crank is... I'd run it on this crank for sure if I have to silver solder it back together, of course, but the bearings just aren't good enough, though. And like I showed you on that one, there's a lot of play. So I could bore them and sleeve them, I guess, or I could make sintered bronze bearings, or I could order some bearings from Stuart. But the eccentric seems to be moving quite nicely now, and the valve doesn't seem to be making much noise. So once I had adjusted the travel on it, it was set up without enough travel, so it was clunking at the bottom. Sometimes you'll have a problem, it'll get to a certain point and you'll bind and you'll want to turn it, and you don't force it, because if this is too long or too short, then you're going to have problems with the full extension of the eccentric, of course. But it's very much like a push rod in a motorcycle, so got that going. I'll check out its gland net next. It could probably be used to tighten it down a bit, use a little bit of tightening, but I'm not going to go for final assembly here. We're just trying to assess what needs to be fixed for sure. I think that this could be reversed. I could put the hub on this side and run it with this facing outwards, but then I wouldn't have his nice AA, BB, and maybe AA was for Alcoholics Anonymous, I'm not sure, but anyways, this #1 is going to be a bit of a challenge, but it's fun. If you can't have fun, there's no point in doing it. Perhaps I was being unkind with the AA comment. Life has different circumstances, and sometimes people get called away to do things and then they have to come back to them. And perhaps he just put it together after he had done a lot of the finer machining and not risk damaging it to for further engineering renovation. So was assembling it to look like the steam engine it was, after doing a lot of work on some of the parts and making them work quite well. But after I straightened out the rod here and the slider foot thing, it's sliding very well, but you can see here where there's these cutouts that haven't been cut out, and they have to be cut out in order to clear the bolts on the slide rails. So this was canted outwards. The foot wasn't properly machined flat. It was filed, so it had a hump on it, and it was on an angle. It was like this, and I had to make it square again. So this wasn't machined finished, so he got stopped after he did the bore and he did all the tapping, and he got the frame built, and then he got to the point of the crank, and he didn't want to machine the forged crank, so he made a pinned crank, which is offset, as you can see there. Here it's not really centered in these squares. Not sure how much that's going to matter for a low speed engine at this point, but I'm going to have to machine out these shoulders to get clearance on the slide now that the rod is actually straight up and down and the pistons are machined to fit the bore. So it had a lot of oiling gear on it too. He had built this oiling thing here that was feeding everything, so it looked like it was working, and maybe it was working, and then somebody, like I said, put bits and pieces on it that weren't meant for this machine. But this is indicative of not being finished, because that's a simple machining procedure, and maybe he didn't have a milling machine at this point. Maybe he lost the milling machine after he did a lot of the flat surfaces, like the covers and that kind of thing. So the mysteries abound with these old engines. You just don't know really what happened. It could have been through the Blitz and burned in a building. Who knows? So there we go, folks. That's the end of today's journal. A really long one.